I'm Nicholas and I'm here to talk about the rate of reaction. Rate of reaction is a measurement of how quickly product is formed or reactant is used up. There are three main ways to measure the rate of reaction. The first one is gas collection. If the production of the reaction is a gas, you can measure the rate of reaction. As long as you measure the volume the plunger gets pushed out and the time, you can calculate the rate. The next one I want to talk about is change in mass. If a solid reacts to form a gas, there will be a change in mass. If you measure the starting mass, the end mass, and the time period, you can calculate the rate. The last thing I want to talk about is precipitation. If a liquid reacts to form a solid, the time taken for the solid to form will be the rate. In this example, we can see the X disappearing as the precipitate blocks the view of the X. The equation for rate is concentration change mole per decimeter cubed over time in seconds. There are a few things that can affect the rate of reaction. The first thing I want to talk about is temperature. As the temperature increases, so does the rate of reaction. This is due to two reasons. One, more particles have the activation energy needed to collide, thus have more successful collisions. Second reason is, more particles have more kinetic energy, thus moving around more and having more collisions, increasing the rate of reaction. Next, I want to talk about the concentration or pressure. If the concentration or pressure is increased, that means there are more particles per unit volume, thus more collisions, increasing the rate of reaction. The last thing I want to talk about is surface area. As the surface area increases, that means there's more particles to collide with, thus increasing the rate of reaction. Catalysts can also increase the rate of reaction. It does this by providing an alternative reaction pathway. Also, they lower the activation energy required for a successful reaction, thus increasing the number of particles with that activation energy, in turn increasing the probability of a successful collision. Enzymes. Enzymes are biological catalysts that increase the rate of reaction. They have a wide variety of uses, from helping digest your food to being used in manufacturing of rubber. The lock and key hypothesis. This theory states that the shape of the active site matches the shape of the substrate molecules so that they fit together like a lock and key. This makes enzymes highly specific, and usually each enzyme only works for one type of reaction. If an enzyme is exposed to harsh conditions, the active site will change its shape or denature, so the substrate will not be able to fit the enzyme anymore. Let's look at some practice questions. Dilute hydrochloric acid reacts with sodium thiosulfate to make the product shown in the equation below. Use the equation to work out the formula of sodium thiosulfate. There are two ways we could go about doing this. The first one is learning the formula of sodium thiosulfate. The second one is using reasoning to determine the formula of sodium thiosulfate. If we look at the equation, we can see there's two sodiums on the right, which mean there would be two sodiums on the left. There's also two sulfurs on the right, which aren't on the left, and three oxygens. That would make the formula Na2S2O3. The next question. The symbol AQ in the equation tells us the substances are aqueous. What is meant by this? Aqueous basically means it's a solution in water. The last question. The rate of reaction can be studied as shown in the diagram. We've seen this diagram on a previous slide. Use the information from the equation to explain why the cross disappears. If we look at the equation, we can see sulfurs formed, and sulfur is a solid. This would prevent us from seeing the X. Student studies the effect of temperature on the rate of reaction. He obtains the following results. Another student said one of the mean values was incorrect. Identify the incorrect mean value. Give your reasoning. If we look at 45 degrees C, we can see we have 21 seconds, 23 seconds, and 29 seconds. 29 seconds is obviously an anomaly, as is outside the 2-second range that you should use to calculate the mean. The next question. State what conclusion can be drawn about the effect of temperature on the rate. Explain your conclusion using particle theory. As the temperature increases, so does the rate of reaction, as particles have more energy, thus move more faster, thus increasing the probability of collisions. Also, you can talk about activation energy. As more particles have the required activation energy, rate will increase. Enzymes are biological catalysts. State what is meant by the term catalyst. A catalyst speeds up the chemical reaction and lowers the activation energy. The following graphs show the activity of two enzymes, A and B, with varies in the pH. Use the graphs to compare the activities of the two enzymes. If we look at the graph, we can see A works between the range of 0.5 and 4.5, whereby B works in the pH range of 3 to 8. Last question. Enzyme C is found in saliva. It works between pH 5 and pH 9, but is best at neutral. Sketch on the grid above how the activity varies with pH. Now it says between pH 5 and pH 9. Basing what we know on the two other graphs, we can see it peaking at about 7 or 8 and dropping down from 9 and starting at 5. Thank you very much for listening. I hope this helped.